Hey everyone, welcome back to another exciting math session. Today we're entering the circle zone, where pizza slices and chords meet geometry. Ever wondered what part of the pizza slice is the sector and what's the segment? Well, imagine you cut a pizza from the center. The wedge-shaped piece you pull out is the sector, the region enclosed by two radii and the arc between them. Now, if you slice that same pizza with a straight line instead of radii, the smaller curved piece you get is the segment, which lies between a chord and an arc. When theta, the central angle, is less than or equal to 180 degrees, it's called the minor sector or segment, and when it's greater, it becomes major. So basically, a sector is like the full pizza slice, and a segment is that small topping cut by a chord. Simple, tasty geometry. Alright, moving on. Have you ever seen the edge of a wheel or a pizza crust and thought, how long is that curved part? That's what we call the arc length. The entire circumference of a circle is 2 pi r, which represents 360 degrees. So, by the unitary method, the arc length is equals theta by 360 into 2 pi r. But wait, if theta is given in radians, it becomes even simpler. S equals r theta. And here's a fun part. If you want the major arc, just replace theta with 360 minus theta. So next time you measure a wheel's rim or cut a circular cake, remember, that curve you measure is nothing but the arc length. Mathematically delicious. Now imagine coloring that slice of pizza. The area you color is called the area of a sector. Since the full circle has an area of pi r square, corresponding to 360 degrees, the area of the smaller slice, or the sector, becomes A equals theta by 360 into pi r square. And if you're working in radians, it changes to A equals 1 by 2 r square theta. Easy, right? If you want the major sector, simply subtract the minor 1 from pi r square. So whether you're finding how much frosting covers a circular cake slice or measuring an angle in physics, the area of a sector gives you the portion of the full circle. Degrees for school, radians for pros, that's the deal. Okay, now comes the smart trick, finding the area of a segment. Picture this. You have a pizza slice, sector, but you only want the curved edge part, not the triangle near the center. So, the segment area equals the sector area minus the area of triangle OAB. The triangle's area is half r square sine theta. So the full formula becomes A equals pi r square theta by 360 minus half r square sine theta. This formula works beautifully for small angles, theta less than or equal to 180 degrees. For larger ones, just take 360 minus theta or subtract from the total circle area. So basically, geometry gives us the perfect math recipe to calculate even weirdly shaped slices. Now, let's talk about chords, the unsung heroes of the circle world. Draw a perpendicular line from the center O to the chord hub, meeting it at M, boom! You've created two right triangles. In each triangle, AM equals our sine theta by 2 and OM equals our cosine theta by 2. That means the chord length equals to our sine theta by 2, and the triangle's area can also be written as half r square sine theta. So whether you're designing a Ferris wheel or figuring out the span of a bridge arch, chords help you find lengths and heights easily. It's pure geometry magic mixed with trigonometry fun. Alright, math enthusiasts, time to get our hands dirty with numbers. Let's take radius r equals 21 centimeters, angle theta equals 120 degrees, and pi equals 22 by 7. Step 1. Find the sector area, which equals 120 by 360 into pi into 21 square, giving us 462 square centimeters. Step 2. Find the triangle area, equals half into r square into sine 120, which is 441 root 3 by 4. Now, subtract that from the sector area, 462 minus 441 root 3 by 4, and tada! The segment area comes out to approximately 271.04 square centimeters. Geometry in action, from formulas to real-world measurements. Before we wrap up, let's do a lightning speed recap so you can ace your exams. Arc length equals to pi r theta by 360 or r theta in radians. Sector area equals pi r square theta by 360 or half r square theta in radians. Segment area equals pi r square theta by 360 minus half r square sine theta. And chord length equals to our sine theta by 2. Always check whether theta is in degrees or radians before using these formulas. That's where most students slip up. Keep pi and root 3 in symbolic form unless told to simplify. And remember, circles may look round and simple, but their geometry connects to everything from satellite paths to slice cutting patterns. And that's the fun of math. It's everywhere. In the next video, we'll explore how these same formulas apply to real-life engineering and design. Stay curious and keep calculating. See you there.